Hey guys, welcome back. I know you have missed me, and I have missed you in return. Sad days, but let's do some math to make ourselves feel better here. We're talking about the inverse of a function or a relation, part one. Okay. The idea here is that if we can reflect a point, then we can reflect whatever we want, whether that be a relation, a function, a geometric figure, whatever. So a point reflects over a line if it is the same distance from the line after the reflection and the line segments connecting the reflected points are perpendicular to the line of reflection. Those are a lot of words to state the obvious. So let's state the obvious. Okay, you might want to pause the video, but I'm going to go ahead and say here the answer is C. I mean, surely you can recognize that A and C are reflect over line L there. Okay, and the reason why is that this little segment here, that length gets repeated here, and we create a right angle there or perpendicular. All right, so that was C. Now, for whatever reason, if the line that we reflect over is diagonal or rotated in any way, it can be harder to see. It can be harder to see for me. And some people see it better than others. Go ahead and answer that. But this one is F. So we want to create the right angle and then repeat the distance. And so it is F. You might want to look at that figure, but let's move on. Okay, which could be the equation of line L? Well, that's as basic as it gets. Surely you get that this is C. You back up a second. This number right here is at the Socrative quiz. That's your number. When I refer to problem number 3 or problem number 1, you need to be looking right there. Some of you are missing that. All right, let's move on. Definition. Inverse of a function or relation. The inverse of a function or relation is its reflection over the line y equals x. That is a definition. We don't really argue too much with definitions. We just say, okay, it's a definition. Pause the video and see if you can answer that. A lot of people will miss this. It is not D, it is E. That when we bring that to here and that to there, those are about the same distances and it's perpendicular. All right, well, let's see what's going on with the coordinates of A and the coordinates of E. So let's get them. Let's look at them a little bit closer. Let's analyze it. 2, -1, -1, 2. The 1 stays negative. The 2 stays positive. All that's happening is the X and Y coordinates switch places. Well, that's it. There's not a lot going on here, but it's math and it can transform into some trickier stuff. If you wanted the mapping rule, it's right there. I'm not really going to focus on that too much. I'm just saying it didn't highlight. It's okay. Let's move on. All right. So here's number 5. Pretty simple question. See if you can answer that. The answer is C. And it's simply the 3 and 2 switch place, the 10 and 0 switch place, the 8 and -5 switch place. Just switch X and Y, and that's the inverse. Moving on. Now, we might need to focus on that symbol right there. You read this whole thing as F inverse of X. F inverse of X. You don't read it F to the -1 power. Whatever you say in your head is fine with me, but that's just not the way you read it. All right, now let's answer the question that clearly it is C. That you're just switching the 4 and -2. Moving on. See if you can answer that. We are reflecting over this line. I do believe that the answer is B because you bring that in and we kind of create that right angle there. But that's probably not the best way to do that. The best way to do this problem is do the coordinates of A, which are 2, -4, switch them to -4, 2, and that maps to B. Left 4 up 2, not my best 2 ever. All right, pause the video and see if you can answer that. We are reflecting over that line. A is on that line, and if a point exists on the line of reflection, it stays put. So A maps to itself. The answer is A. You could do that with coordinates as well. All right, take some time. Pause the video. Take some time and answer that. All right, we are given a graph of f of x. We are asking for, well, what point would be on the inverse of f of x? And so this will be a theme that we will have, is that we have a graph of one of the functions and we're asking about its inverse. Okay, so to find this answer, we want to switch these and plot it. If I switch those and plot -2, 4, I'm right here. So it's not back onto f of x. If I switch these and graph -2, 2, left 2, up 2, I'm not on f of x. If I switch that and graph 4, 3, 1, 2, 3, 4, 1, 2, that's pretty close, but we're not interested in close. It's still wrong. If I graph this one, -4, -2, left 4, down 2, 1, 2, 3, 4, 1, 2, we hit it. And that makes that the answer. Again, that will be a theme of what we do here, is that we have a graph of f of x, and we're asking a question about f inverse of x, and we have to switch. Like this. Might want to pause the video. Got a couple more problems here, and that'll be it. Okay. This 5 relative to f inverse is an x value. There's no doubt about it. It is an x value. Well, we don't have a picture of f inverse. We have a picture of f. F is the stars in the problem. So since we have a picture of f, we want to interpret picture of f. Then 5 is a y relative to f. And so if we draw this line right here, every point has a y coordinate of 5 on that red line that I just drew. And clearly we're talking about this point. And so the answer would be -3, C. Okay. Keep in mind that a question like this it's describing one coordinate and the answer is the other coordinate. And the other coordinate here is -3. I think we have one more. G inverse of -2. Pause the video and see if you can answer that. All right, again, this -2 relative to G inverse is an X. But we don't have a picture of G inverse. We have a picture of G. So we want this -2 to be a Y. -2 is a Y value. And if we draw that line, every point on that red line that I just drew has a Y value of -2. Well, we're asking about the G function, which is here. And then both coordinates would be -3, -2. Okay. And then we want the other coordinate, which in this case is -3. All right. So inverses just switch coordinates. We will do that with some equations in part 2. Let's do our cameo appearance. Drum roll. It is Mr. Sulu from Star Trek. Oh my. All right, guys, we'll see y'all